Hello everyone, let's try to solve this question together. So here we have a newborn infant who is delivered vaginally with an EPGAR score of 9 and 9 at 1 and 5 minutes respectively. In the nursery, she was noted to have jerky movements of all four limbs. An electroencephalogram was obtained. The image is shown there. So the best statement about this case is, pause the slide, zoom the picture, look at the options. Okay, the correct response here is A, more than one waveform is seen. So let's see why the others are not the right choice, and then we will dissect more into the choice A. So the is suggestive of EEG, suggestive of HIE. HI is hypoxic ischemic encephalopathy. First of all, this baby was normal with a normal EPGAR, so there is nothing really suggestive that the patient has hypoxemic ischemic injury. So one is that is out. Other thing, we all know that this EEG looks normal, and that's why you don't have to worry about, you don't see any burst suppression pattern and other problems which can in so this is kind of the findings in the HIE, which is not the case here. So that's why choice B is not the right choice. What about that this EEG is suggestive of seizures? Again, like I said, let me rub it off. We don't see any spikes of waves. It looks like a normal pattern going on all along. So that's why seizure is also out. And what about deep sleep? So again, a deep sleep EEG will have the waveform, the delta, and which is very low amplitude, low voltage kind of. So that is again out. And deep sleep is a word, is deceptive anyway. So that should not be the answer here. So now let's dissect it more and learn more about the EEGs. So EEGs, that's the nomenclature. Is looks very confusing, but if you remember honestly, like it's so easy. Like F is frontal, and as you see, like these are the nomenclature here. So again, so this is centroparietal, this is left, this is right, this is occipital. So if you see something like O1, O2, they are talking about occipital lead, and so basically the seizures or the activity is coming from that area. So basically this maps, basically points out where the problem is. So for example, let's go to the next slide. So we'll play that. So these are the four waveform, and this is a small video which I will run, and I will so see delta waves. Keep looking on this bar, and this will show how these delta waves are changed to theta waves. Let's play it. So see delta wave. Now you see it's like really a slow wave. Then we go to theta. See the waves are like more compressed now. Then we go to alpha, you see like the waves are really, and now when you go to beta. So these are the different waves, slow to fast. So just remember that. Again, showing on the same token. So going back to the questions, we already talked about B, C, D are wrong. So why A is right? Because now we see there are multiple forms of waves seen here. So if you see here, you can see like there are like, see, these are compressed wave. These are somewhere you have slow waves, fast wave. So there are a lot of forms of waves, and this is a way to remember that beta wave are the fastest, and they are the awake mental state. Alpha is also awake and resting, but theta is sleeping and delta is deep sleep. So just remember that, and many questions could come from just these few slides. And again, EEG is not, we don't focus on EEG that more. We usually learn a lot about ECGs, which is electrocardiogram, with the P wave, T waves, and QRS complexes, PR interval, and a lot had been taught in medical school. But EEG somehow or other, is not taught in detail. But again, this is not the lecture on EEG. I just want to tell basics of it. It's not difficult to understand. That remember delta is the slowest, then theta, then alpha and beta, and you can now make out on the EEG. Also, by looking at the numbers and nomenclature, don't get worried. It's very easy. If you have F, that is frontal. If you have CP, that is cerebral parietal, centroparietal. If you have O, that's occipital, right, left. So it's so easy. And if you have right, left written to it, if you have a Z, it means it's in the central. So it's not that difficult. It's honestly, when you see the print now, you should not be worried. At least try to diagnose it. And now you can run through the AI any image could be seen by any AI, and AI can give you a little bit of diagnosis on that. So try to use that also. So it's not that difficult these days. So again, but one thing is, you have to know that in real time, it's very difficult to see one frequency. The frequency just overlaps because brain waves are really interesting. So that's, you have to know that. And this is a very nice lecture. If you guys can see on this link is given here, and or you can type normal neonatal EEG and put the author's name on the search. You will get to this presentation. It's very nicely done, and it explains a lot on how to interpret the normal neonatal EEG. So I hope you guys have enjoyed the video. Please do like and subscribe to our channel, and you guys have a wonderful day. Bye.